Hi, Ananthan.
Hi.
My co-presenter.
Hi.
How are you this morning or this afternoon?
Yeah, very fine.
Excellent, excellent, excellent.
Hi, Julian. Hi, Ananthan.
Hi.
So I'll just give a brief introduction to the session, and then you can begin the session, right?
Yeah.
Okay. Good afternoon, everyone. Myself, I am Nikhil V. Chandran. I am the co-organizer of the Hyperledger Kochi meetup group. So welcome to the expert session on Besu, an Ethereum client by Hyperledger. Today we have with us the distinguished guest, Julian Gordon. He is the Vice President, Asia Pacific at Hyperledger. Julian started his career in London, working in technology within investment banking at HSBC, Lloyds Bank, and Kleinwort Benson. He then spent the past 20 plus years in Asia Pacific business development and leadership roles within technology companies like HP, Sun Microsystems, Juniper Networks, and Cisco. Julian is a strong advocate for open source and truly transformational potential of blockchain. The other guest we have is Ananthan Rajashekaran. He's a research and development engineer at KBA, an active developer and blockchain enthusiast with more than 3 years of experience in multiple blockchain domains. His expertise include Ethereum, Corda, and apparently Besu. I welcome Julian and Ananthan to Blockhash Live 2020, and we are delighted to have you with us. And also some housekeeping tasks. If you have any questions during the presentation, type them into the chat, and at the end of the session, you can unmute and ask the questions. So over to you, Julian, for the introduction, and I hope we have a good session.
Okay, excellent. Thank you, Nikhil. That's great. I'm going to share some slides now, so I'm going to see whether that works, which I'm sure it will. So here we are. Yeah, so can you guys see my slides?
Yes, we can see now.
Okay. All right. Firstly, thank you, Nikhil, for hosting this today and Blockhash. This is a great event. I know it's the meetup for Kochi and Kerala. And last year I was in Blockhash. I just wish I was there again, but obviously we all know that that's not possible. But next year. Actually, my brother in the UK just got his vaccine. So he's a doctor in the UK, so it's happening. So we're getting vaccines at last. So hopefully we'll be past this at some point, hopefully this year. So today I'm going to talk do a little bit introduction to Besu, to this Besu talk, and then we're going to go to the true expert, which is Ananthan, who's going to go into more of the details. So what I thought I'd start with, really just, in terms of Hyperledger, we all know Hyperledger. I think now open source blockchain technologies within the Linux Foundation. But what makes it special and why we have grown, and it's really just the heritage that also came with the Linux Foundation, is that we are truly, truly, truly open source, right? So the Hyperledger technical community is 100% open. So all the technology, Besu, everything that we talk about today, you can just go to GitHub. And of course, a lot of people then take that technology and wrap it around other technologies, a lot of cloud providers and others, and they write applications on top of that, and obviously provide a service and may charge for that. But the technology itself is free. There is no gotcha. And also what makes that possible is the technical community. We are about coding, and it's all about the technical contributions. And we have what we call a do-ocracy, as in D-O-ocracy. So we are driven, the people that do, the people that get involved, the people that contribute to the projects, those are the ones that ultimately run the projects and have the influence about what happens in the projects. And we need more, we're always looking for more and more people, because we're developing this code for the common good of all. This is the Greenhouse, which I think you're all very familiar with. Particularly projects like Hyperledger Fabric, Hyperledger Sawtooth. This is a family. We started up with 2 code bases with Fabric 5 years ago. Actually, Fabric, I think it was in February 2016, and actually the project started next week is our 5th birthday for Hyperledger. So we're going to have a big celebration. I'll talk about that in a second. So those are the big projects. We had Burrow early on from an Ethereum perspective. I mean, those were mostly permission blockchain. We had Burrow, of which you could write, it's an EVM, and you could write Solidity contracts. That actually now sits on top of Fabric and Sawtooth. We have a bunch of libraries, a bunch of tools, and we have a great lab. I'm not going to go into those today, but the one with the subtle red circle around it is the one we're going to be talking about today, Besu, which I think was August 2019. And this is a culmination of a lot of discussions between the Ethereum community and the Hyperledger community. We've always, I think, since the very beginning, wanted to have Ethereum. We're about code, and we love all different technologies. So I think you can now, with this, we'd like to have a spectrum of stuff that can run on the mainnet to the most permissioned kind of DLT. So we have the whole spectrum of technology. And to give you a little bit more, this is a slide I actually got from the Besu team. They gave it to me last night. I said, have you got any slides? This is one of them. So this is kind of like, they kind of show how the two came together, right? The two different worlds. So you have on the top, Ethereum was announced back in 2013. You know, we obviously started with Bitcoin, as we all know, and then we had Ethereum with Vitalik and many others, right? And out of that, you know, was smart contract and all the things that we know about Ethereum today, the one world computer. It was launched. Consensus itself was also founded, which was founded by a number of the founders of Ethereum, and they started a company called Pegasus. At the same time, EEA was founded. That's the Enterprise Ethereum Alliance. Now, the Enterprise Ethereum Alliance, a lot of people say, how does that compare with Hyperledger? Well, Enterprise Ethereum Alliance is a standards body, right? And maybe even not have the word Ethereum on it, because it uses its technologies. They have a lot of standards which are not just about Ethereum. So if you look in the world of all these organizations within blockchain, you know, the developers, you have, you always, and this is what Brian Bellendorf always talks about, you have people who create standards. So that's EEA, right? There's people who manage standards, who regulate standards, and there's people that write code. We write code. EEA writes standards. So there are a different type of organization, right? And then they launched Pantheon, which started this Ethereum client, which ultimately became Besu. At the same time, in parallel, Hyperledger launched 2016. Consensus actually was one of the first early members of, as you know, as I said, always Ethereum's always been close to Hyperledger, and then Fabric was started. Then we have Sawtooth, Burrow, and then EA joined. And at that time, the conversation came together, and Pantheon was contributed to Hyperledger, and it became Hyperledger Besu. And now, in March 2020, Hyperledger Besu became active as a version 1, and now it's just grown and grown and grown. And if we look at the next slide, if I can get there, you know, there's been a lot happening this year since really August 2019, and that was a big year. I remember after it replied, we did a big meetup in Beijing. We had Joe Lubin there, and there was a lot of noise, because this was a very significant step in having an Ethereum project like this within Hyperledger. They've had 40 releases this year. They got 60 contributors. They presented at the Global Forum. I'm not going to talk about the features. I think Ananthan is going to go through that. And they gained active status in 2020. So, and they created a transparent and open, as I said, the key thing is transparency, and they have a very open maintainer process. And I'm going to talk a little bit about that in a second. I just thought I'd share this slide, because in the end, we're talking about the technology, but what is the technology used for? I was doing a presentation to a university about, I think it's in November, as you can see from this slide. And that week, I just had a look, what's happened in CBDCs? And there were 4 different announcements, major announcements. And if you look at them, the first one, Reserve Bank, that's working with Consensus. Second one is, we don't actually know what's the China banking, CBDC, but that's a separate kind of thing. Then we have the Bank of Thailand, which I know is Besu. They announced they're working with Besu. And then actually Cambodia, which we talked about earlier today, is Aroa. But the thing is that CBDCs are using, and these private proof of concepts are using Hyperledger Besu, and Hyperledger Besu is being used by real applications out there today. So it's not just something it's something that's live and running and capable to run production systems, and in one of the hottest areas, CBDCs. So how do you get involved? as with everything at Hyperledger, you have any Hyperledger project, you can go to our wiki, you can go to GitHub, we have chat. I hope everyone knows how to use chat.hyperledger.org. If you don't know, you get Linux Foundation ID. You can contribute. We want people to contribute. We always like people to learn about it, use it, and then contribute back. And we do have a thing called Besu Quick Start. So before I hand back, so that's really an introduction about where Besu is, and I position it within Hyperledger. I just want to finish with two other things, right? We have this developer newsletter now, so I will put this sign up in the chat. If you sign up for this weekly, you get a newsletter, and this is a newsletter created by our developers for our developers. Actually, it's a wiki that's opened up in the beginning of the week. You can put ideas into there, and then they develop it, and out it goes on the Friday. The interesting thing, it has noteworthy pull requests that goes through all our projects, and they think, oh, this is an interesting pull request that you may, as a technologist, be interested in. So that's one thing. And this week, I noticed they had an update, quarterly update on Besu. So this is a good way to keep, and this is for tech, not with the more marketing kind of thing. This is really for technologists. And finally, I want to talk about, we're very excited, we're 5 years old, which when I was 5, I was quite small, but actually for blockchain, 5 years is a long time. And we're 5 years old, and we have a celebration next 18th, next Friday, which everyone is welcome to turn up. Brian will do a quick overview of the year, a bit of a celebration. We'll do some AMA, and then we're going to break out into different sessions for a kind of networking activity. So please do register for this as well. Okay, I will now hand it to the true expert. Ananthan, if you could now take us through details of what is Besu. Thank you.
Thank you, Julian. That was a wonderful introduction to Besu. So if any of the participants want to ask questions regarding the introduction, you guys can post that in the chat, and Julian will take it up.
Okay.
So, let me start with the Besu. So hopefully let me start with sharing the screen. Okay, so I hope everyone can see this. Okay. So what is Hyperledger Besu? So as Julian gave us a brief introduction, it's an open source Ethereum client. So simply saying, it's an Ethereum client developed by the Hyperledger community. And they did a very hell of a job at it, and it's a very good client. So it is basically written in Java, and using that, you can do everything that you do using a normal Ethereum client. Like client, you can connect to any of the private or public Ethereum networks, or the main Ethereum networks, or like the test networks such as Ringabir, Option, etc. And the best thing using Besu is that you can construct private networks. And Besu currently supports proof of work and proof of authority consensus algorithms such as IBFT and the click. So there will be more on that in the next slides. So where can we use Besu? So basically Besu we can use in a secure and high transaction rate private blockchains if needed. And it also, apart from the other features such as the mining, sending transaction, or executing smart contract, we have privacy and permission. Now, look more into the features of Besu. So basically, Besu implements the standards defined by the Enterprise Alliance, and also it's an implementation of Ethereum virtual machine in the Java. So basically, you can deploy smart contracts and execute them in the Besu private network, or if you use the Besu client. Now, consensus, there are actually 3 consensus mechanisms that are supported by Besu. So there are 2 proof of authority variants. The first one is Istanbul Byzantine fault tolerance 2.0. And basically, the transaction and blocks that comes into this network are validated by some people called validators. So basically, it's the same name that given to miners, those who validate and commit the block. So one validator will propose the block, and the others will validate and endorse that block. Then they can be committed into that block. So IBFT has immediate finality due to that fact. There won't be any forked or angle blocks on the main chain. Every block, every valid block will be committed to the main chain. Now, for a transaction to be committed, you need to at least 2 by 3 of the validators operating on that same block to create. And if your network, like if you're like running a test network, you at least need 4 validators to commit a block into the chain. Then the next one variant of proof of authority we have is a click. I mean, these are like just like different names that we name them. So it is actually a more fault tolerant than IBFT, because you only need half of the validators to validate the block, and the existing validators, I mean, multiple validators can propose the vote and remove and add the validators also. Now, due to this fact, like click doesn't have immediate finality, and there should be possibility of forking or ungrouped nodes in the main chain. Now, finally, we have proof of work, our good old consensus algorithm, and yeah, those are the 3 consensus algorithms supported by the Hyperledger Besu. So basically, if you are connecting to the main Ethereum network, the consensus algorithm will be proof of work. I mean, I hope they will change that to proof of stake in the near future. Others will be available. All these algorithms will be available if you are like trying to set up a private Ethereum network. Now, as usual, with the normal clients, Besu can also perform a mining within the network, do transactions, deploy smart contracts, and interact with the decentralized applications. Apart from these features, the best features that are introduced by Besu, that is they are like implementing the standards defined by the Ethereum Alliance. So the first one is privacy. Basically, you can create private groups. That is basically, you have an entire network and you can create your own groups inside that network, and the transactions that are sent between inside these networks will be private only to those participants. So the participants in the group can only see them and like have a transaction between them. So to achieve this, Besu is actually using a private transaction manager called Orion, which is actually part of the quorum privacy protocols, and the quorum block, basically the quorum blockchain's privacy protocols, and they are using the Orion node to keep the private transaction, and the Besu will keep track of the state of these private transactions. The next main feature of Besu is that we can we can specify which accounts in which the transaction, I mean, which have the transaction abilities, or who can write into the blockchain, all those things. And then we can specify which node can enter into the blockchain network also. That are the main features that Besu adds, and that are the very important features that Besu adds. Apart from that, this is actually one of the necessary feature when we are actually running a node. The Besu provides us with best monitoring softwares that are available, and it is tested, and you can like connect with them and explore. And also we have Eletho, which is a block explorer, and Gafna, Prometheus. These can be used to monitor the health of a Ethereum node or the Besu client, and that will be very helpful when we are actually using that on an enterprise platform. Simply, what can you do with the Besu? So you can create private networks. Besu is actually a command line interface, and I mean, all these tools can be used to provide you with an overall working condition or the status monitoring of that Besu client. And it will be always be running a JSON RPC. I mean, you can communicate with the JSON RPC via HTTP or WebSockets, and you can gather all the details regarding that. Now, Besu is developed by Hyperledger, but that doesn't mean it doesn't support anything that is on the other end of the part. So Truffle, Remix, Web3j, and there is also an Ethersigner developed by developed in Apache 2.0 license, because the Besu, the input Besu doesn't have just like other clients like Get, it doesn't have a key manager. So you can either use a third-party key manager just like MetaMask, or you can use the Ethersigner which is provided by the Besu itself. Now, what are the main benefits? Basically, we can use Besu to create a private network if you have the need, or your use cases arise, those kind of things. So that will be better. I mean, I've been playing with Besu, and it's actually a better client. I mean, you may know that it's a CLI, but it's a better client than most of the other Ethereum clients, because you can they provide you a much smoother experience. So you can just directly connect and interact with them. And they also that Besu, the developers of Besu has provided us with a neat and well maintained documentation. So in any case, if you want to explore the other things that are not like listed over here, then we can like go ahead and do that. So now that's all about Besu. We can now go ahead and talk about how we can create a private permission network and how it will be working. If you guys have any like doubts, you can like post that in the chat, so we can go into that too. Okay, so first let me tell you about the development environment. I mean, there are many options in which you can actually install Besu. So I mean, you can use the Docker. You can use the you can use it with the help of the Docker, or you can directly build the Besu from the source code, or you can use it using the installing the binary. So basically, Besu is a Java client, so it will need the Java versions. Yeah, sorry. So I hope you can see it. So the Java, I have tested it with the Java 15, JDK 15. So basically it only needs JDK 11 plus, or any versions that is above 11, you can use that. And for the Besu, I am using the 20.10.2 version. So that's actually the latest version yesterday. So that there might be any, there could be some improvements. So yeah. So you can either use the Docker and pull out the images and run them, or so I just want to know how the things work in a deep way. So I'll tell you guys how I did this, how I set up the environment. So the best way is to download the Java SDK. Like you guys can just go to the Oracle's page. And there you can download the Java JDK. And you can download it for any of the versions. Like for what I did for my Ubuntu version is that I downloaded the Linux 64 compressed archive. So basically you can just download that. And this is the archive. So you can just open that using an archive manager, or any 7-zip or something like any of the compressor managers. So then just copy this folder to any of the location that you want, and you just need to set up the environmental variable for that. So like you can set the environmental variables in many places within Ubuntu. In case of Windows, you can just directly go for the environmental variables for in the My Computer options. And for Mac, it is also the same. So for me, what I did that, I used gedit and I put them in the /etc environment location. So I hope you guys can see this. So this is basically where you can specify the environmental variables for Ubuntu, and I have already specified it for Java and Java and Besu, and also these are the where the executions remains, the executables are located. And as most of the clients that runs with the Java needs the Java home environmental variable, where it will be specifying where you have installed or where you have like copy paste your JDK. So this will be the home page, and you can just provide that address over here. So that's all about the development environment of Besu. Now we can go ahead and set up an actual private network using Besu. Then we will see how a fully fledged Besu network is working. And also we will see how the other tools such as MetaMask, Remix ID can interact with the private network that is set up to using Besu. Okay, so in any case, if you guys want to find this later, you guys can like go to this location. So tutorial said that we have called permission and create a permission network. So I'll be just following this documents to create a permissioned network for us. So I'll just put this in the chat. Okay, so basically, I'll just go through what are the steps that we'll be doing. So first we'll prepare an environment like some directories for storing the data regarding each nodes. So we'll be like creating a private permission network consisting of 3 nodes, and we'll be setting up two accounts to do the interactions, and 3 nodes can communicate with the within the network, or like can only join the network. We'll be doing that kind of setup. So first we need to create an folders where we can specify where we will be storing the data for that particular node. Then we can create an address for a particular node, because when we'll be building this network using the click algorithm, which is a proof of authority variant. And for the click algorithm in the Genesis file, we have to specify at least one proposer or validator. So we can create the address. As I mentioned earlier, it doesn't have any valid management, but it allows you to create addresses. So like the key pair, private and address key pairs can be created using Besu. And after that, we will configure the Genesis file. Then we can configure a permission file. I mean, as I told you earlier, we can specify which accounts can write and read from the Ethereum network. So we'll create a permission file, and we will specify 2 accounts to be permissible to write from the network. So anyone can read from the network. Then we can specify which nodes will be able to interact with the network, and we will start the 3 nodes. Then we will add that nodes into the permissioning file. Then we will connect them together. So that will be our entire how we will be setting up an Ethereum private network using Besu. So let's just go ahead and see how we can do that. Okay, so let me just create a new folder from our lab. So Besu lab. Now over here, I'll open a terminal, and I will create the folder structure. I mean, this is the folder structure that we'll be going to need. So yeah, for me, it will be Besu lab instead of permission network. In Ubuntu, we can create mkd using this mkdir and -p for like creating repetitive directory. So data for node 2, then for node 3, and we will get a structure like this. So after creating that, we can go ahead and create a public key and the corresponding private key for that. And to do that, we can use this corresponding command. So basically, as you all know, Besu is actually a command line tool. So this will be the main command, and these are all the parameters that we will be specifying. So we need to actually need to run this inside the first node folder. So let's just make it our way over there, and let's run that command. Otherwise, these are paths. So this is where we specify where we should store the data, and this is where we are specifying where we should store the node key related. I mean the public, the address and the private key related to this generation. Okay, so we look at the folder structure again. We can see there are 2 new folders. One is the key and node address. So if we go back inside the node 1, and you can see there are 2 new folders. And if you like go ahead and open it with an editor, so you can see this is the private key, and this is the address that we need. So now next we need to generate the Genesis file. So basically some other Ethereum tools might have some tools for generating, but we can get the Genesis file from the development documents over here, and we can just modify them. Now, first let me just create that, and I'll just tell you guys what are the components inside that Genesis file. So we can just name it. So let's go back to the root directory. Mine is the Besu lab. So let's name it gedit. I'll just call it genesis.json. It is a JSON formatted file. So you have to specify the extension as JSON and paste over here. Okay, before explaining, the first thing we need to do is that we need to specify any one of the validator's name inside the Genesis file. So that's why we created the node address for that. So when you specify, you can avoid this part. So you don't need to include that part. So copy the other part and replace this node1 address over here. So the extra data will be something like this. And now let's just go ahead and explore the details that are displayed over here. So in the configuration, we can specify the chain ID, which is for uniquely identifying our network or our chain or blockchain. Then we are using the Constantinople update version. I mean, over the course of Ethereum, there has been many updates. Then we are using a click consensus algorithm. And the block generation period is 15 seconds. You can get, if you are guys working on that, you guys can provide a lesser interval. I'll go with the default. And the epoch length means when after 30,000 blocks, we will reset the voting pattern and choose a new voter and all those. So that is where we reset the votings and proposals and all those things. Then we can specify Coinbase. So that's actually a default value, so we don't really need to specify. We need to specify the any one of the validators address in the extra data, and the gas limit for the network, and all these others are like normal for a minimum block. So in case of Genesis, we will also have that, but we will be leaving them as empty at the time of creation. Then as you know, this is actually a proof of authority network. So we can pre-fund some accounts with balance. So here we have specified 3 accounts and the balance for them. So you can either see them in hexadecimal or in normal binary format. And you can see there are some private key and comments. So these things won't be written into the actual Genesis block. I mean, based on this Genesis block, we'll be Genesis file, we'll be creating the Genesis block. But so these things won't be written. So you don't need to worry about that. As you know, we don't really have a wallet manager. That's why the developers have provided us with the public address and the corresponding private key for that, so that we can manage that. So you guys, like, if you guys want, you guys can replace it with these generated key and address. I'll just go with the default one. Yeah, so that is all. The other number and gas used is general for a normal block, but for Genesis block, it will be an empty string, empty values, basically. Now, using this Genesis block, do not forget to save this after creating this. Do not forget to save this. So using this Genesis block, now we can go ahead and run our network. But before that, we need to create a permission configuration file for each node. So yeah, you need to create a file called permissionconfig.toml, which is a TML format file, and you need to specify these values inside that. So let's just go ahead and do that. So I'll use gedit to create those files. I mean, you can just create a file in one place and copy them to different places. So gedit. So yeah, where you can like paste this. So as you can see, we are giving the right permission to these two accounts, which are like the accounts that we pre-funded in the Genesis file. Like if you guys want, you can change that too, but I'll stick with the default. I think I have provided the wrong. I provided a space bit in between them. That's why the error. Okay, so let's just copy that. So you have to follow this format. Basically, you have two variables, accounts allow list and the nodes allow list. And you need to open a square bracket, and inside that you can like provide the values in a comma separated manner, and you have to like enclose the values in quotes, double quotes also. Okay, so yeah, that's for the first node. Then for the second one, and finally for the third one. Okay, make sure you have saved all the files. Sorry about that. Make sure you have saved all the files and they are in the correct format. Yeah, now we can like close them because and also come back and just check your structures are saying that the same. Yeah, so inside the data you have something called this config file. Now let's just go ahead and continue. Now we need to start the different nodes. So the community has provided us cliently with the commands for both Mac and Windows. And in case of Ubuntu, it will be same as Mac. So let's just copy them and I'll explain them how this works. So first, we'll run the first node. So let's open a terminal inside node 1. Yeah, so already, yeah, sorry about that. So we just start it again. Okay, I'll just explain the command before executing. So as you know, the main command Besu, then we are specifying where you want to store the blockchain's data. That is where you use the parameter and specify the path. So this is a relative path, and it will like append the present working directory alongside with data. And in case if you haven't created the folder called data, it will automatically create one for you. We created that folder structure because we want to specify we will be storing those node key data. Then we need to specify the path of the Genesis file. Dot means in the previous directory, in the main directory. And actually I have named it as genesis.json. So yeah, so I'll be doing that. Then we are specifying that we'll be using permission nodes config file. That is the you need to load up whenever the client is loading. You need to load up this configuration file and follow those configurations. And then we are also saying that only these accounts, only the accounts specified in that file will also be enabled. Then we will be using, every clients, most of the clients in the blockchain domain are using the RPC API format, and we are enabling the RPC over the HTTP protocol. And we are giving access to these many modules. When we are running this client, we'll have access to some APIs, and there are many API endpoints. There are many groups of API endpoints, and we are just specifying that we need admin, net, API, and a click protocol. So basically, these are for different purposes. We'll know them. And we are allowing all the hosts and all the origins to have access to this particular network. So, particular Besu node. And yeah, that's all for the first Besu node. We'll just start it and hopefully it runs. so seems like I have an error. So what's that? Okay, so it looks like something is running on my my computer. So I need to specify the RPC port also. Looks like some remnant of my experiments. So this is the RPC port. So this is where the endpoint of Besu will be exposed, and you can specify that. So I'll just start it with running in 8541. Yeah, so as you can see, we have no problem, and as we started producing blocks also. So now the next one is I'll just explain about what URL is. So as you all know, when to identify a specific computer in a network, we have something called the IP address or IPv6 or v4 address. And just like that, in the Ethereum network, we call something called node, Ethereum node address. And using that, you can establish connection with another node. So keep in mind about this one, because we need to specify this in the permission URL. Okay, so let's just go ahead and run the other nodes also. So to start the second node, go to the second node directory, open a terminal. So I'll run that in port 2, and I need to change the name of the Genesis file due to the fact that I have changed it. As you can see, there is one more, yeah, so. Oh, yeah, so I think, yeah, it was okay. Yeah, so that was a name problem. Okay, as you can see, we have one more parameter over here, P2P port. P2P port, which is used to actually specify where we can communicate with each of the nodes. I mean, it is for peer discovery protocol, peer-to-peer communication protocol, and endpoint for peer-to-peer communication. So in case if you have not provided that, then it will be 30301. So we can have default values for all those things. As you can see, these are not connected, so they are actually waiting for the peer. Now let's go ahead and run the other one too. I'll just remove the unnecessary command prompts. This guy is over here is actually creating nodes and waiting for other nodes. So let's just run the last one too. So when running the commands, it will be always preferable if you paste them in another text editor and edit them, then change them, execute them in the command line, because there are always some problems if we do that otherwise. Okay, so as usual, I changed the Genesis file's name and the port. Okay, now go back to node 3. Yeah, so seems like everyone is up and running and everyone is happy. So next thing we need to do is that we need to add, currently as you know that inside this config file, you can see no nodes are allowed to connect to this particular node. So we need to specify which node is able to connect to this list. So to do that, we can actually use the endpoints. I mean, there are APIs for establishing or adding data to that particular node. So we can use these endpoints to do that. So let me just copy this. Okay, now using the add nodes to allow list method that is exposed in the Besu client. We can actually add the nodes that are necessary for this these things to connect with each other. Now, how you remember the inode address that whenever we started, we'll have an inode address, right? So that is one way to get that, or you can use the corresponding command to that. And if you guys really want to have an UI interface to that, I hope you guys know about the Postman, which is actually a client that we can use to query the APIs on different sites. And Besu, the developers of Besu actually have given us a one second. Fantastic way in which they have actually created a collection of how we can call all of these APIs, and they have given us you run in Postman. So if you click on this option, you will be redirected to Postman, which is actually the same as the call command. You can query anything over that is hosted anywhere. Yeah, that's actually taking some time. So as you can see, if you these are collections provided by the Ethereum Hyperledger guys. So the Besu Hyperledger developer community. So inside that, you can have access to every node, and they have pre-configured it for our voice. So if I want to know the inode address of the node running on 854.2, which is actually the node 2, I can just request that and get that particular inode address. So it's easier like this. So let's just go ahead and collect all the inode addresses. So this is why I told you guys need to copy this to a node editor and edit it over there. As for node 2, you get that too. Okay, sorry. So then finally we need node 3. So guys can use this to interact with the node. So we'll be calling this method API endpoint, and we can do that for the first node, which is running on 8545, running on localhost 8545 for 1, sorry. Then for 2 for the second node, and for 3 for the third node. So you can just open another command prompt anywhere. Actually, you don't really need to open it anywhere. I mean, in the exact same folder, and just paste those commands. So if you see that the output for that particular commands are result is success, then all this will be added into that node folder. So if I go back and open this, sorry about that. So you can see the inode address has been added for that specific 3 nodes, and now we can connect with each other. Okay, now in the same way we use the call command, we have another command to call another method to connect each node with each other. So that method is called admin.addPair. We can use that method to add, we will first connect the second node to the first node, then third node to the first node, and finally the third node to the second node. So let's just go ahead and do that. We'll calling to the second and third node. So we need the inode address of the first node. So let's just go back to Postman and get that. actually work now. We just, yeah. So now in case of node 3, we also need to connect that to node 2. So let's get the address of node 2. Now we just need to execute these together. So let's just go ahead and execute them. So yeah, now everyone is connected together, and to know that we can like get the peer count for each node. So I just ask the node 1 for the peer count. So yeah, it is connected with the 2 other node, and in case of node 2, 2. So and in case of 3, yeah, same results. So if we go back, I don't need this terminal. Yeah, go back and look at the other terminals. You can see that they are listing out the number of peers that it is connected with, and this was the main one, and it is syncing with the other nodes. So it has imported the blocks that has been generated thus far. So you might think that there are no transactions happening. So why the blocks are being generated? So that's because Ethereum allows 0 blocks mining. If there are 5 transactions, it will mine. Even if there are 0 transactions, it will mine. So that's actually an automatic process that is happening in a loop. So this is how we create an Ethereum network using a private network using Besu. So yeah. If you guys have any doubts regarding that, you guys can post in the chat. Otherwise, I'll show you guys how we can do a transaction within the Ethereum network using something called MetaMask, because we did not have any default application. Default key manager for Ethereum. So I'll just. I have like a meta. So let me just quickly go over the MetaMask installation. If you guys have any doubts, you guys can ask in the meantime. Yeah, sorry about the thing. This was I need MetaMask for.
Hi, Ananthan.
Yeah.
There were a couple of questions before. So one was, can we plug other consensus mechanisms to Besu?
You mean like we generate our own consensus algorithms and plug them?
Yeah.
Currently,
or
no.
any other consensus, like writing a custom one?
No, I mean the Besu community is actually working on that, writing custom consensus algorithms and plugging them. Currently, there are like currently it's not possible. Currently, the only allowed consensus mechanism are the PBFT, click, and proof of work.
Okay. Another question was, do we write smart contracts in Java for Besu?
No, you can use the same smart contract writing languages such as Solidity or the Viper that we use on Ethereum. And if you the Java language that is supported, that is still supported, then you can use it. It's the same process as the Ethereum nodes. I'll just show you an example. Okay, so.
Also, can we expect the security and privacy from Besu like Hyperledger Fabric?
Yes, you can. Now that we have privacy, you guys might not understood the way we committed the private key to the block, Genesis block. That's just there for the comments that won't be stored within the private block. So we can expect the security just like we expect in Hyperledger. If we are running a private network, in case we are like going for the main Ethereum network, it will have the standards of an Ethereum network.
No, I think the question was specific to Besu with respect to security and privacy, like in Hyperledger Fabric.
Yeah. Okay. Sorry about that. So, just like the privacy groups in Ethereum, like the channels, it's the privacy group in group that we use in Besu is similar, not the same, similar to the channels in Fabric. So yeah, we can accept the same security that is we are getting from the Hyperledger.
Does Besu give, okay, I think this is related. Does Besu give private channel communication ledger mechanism inside a network like Fabric?
Yeah, so I'm not completely aware about how the communication that happens in the Fabric channels, but they have inside the privacy groups of Besu, those who are like participants of the Besu can communicate with each other, and the other people will not be able to see the contents of that transaction. And those are within the channel can add or remove new participants or like all the participants within that. And the new participants added will be able to see the history of the transaction that happened within the private.
Okay, I think that's all the questions that we had.
Okay. So, yeah. Okay. So I'll just show you how we can like interact using the MetaMask and Remix ID. I mean, I'll just give you a sample deployment. So yeah. So I'll just set it up very quickly and now, as you know, MetaMask can be used to seamlessly connect within any nodes or any Ethereum network. So I'll just try to connect it with the current node. So to do that, you can go use the custom RPC option within the Ethereum networks menu. So yeah, and we already have some profiles to connect different networks. So I just connect one with the Besu, which will be running on local http://localhost. So the chain ID was the same as we like provided in the Genesis file. So in case if you forgot that chain ID, you can just give it a false value and MetaMask will query it for you and you can just copy that over here. Now, after that, close the network and now we have established connection with the network. And if you remember, we are already pre-funded some accounts. So we can go ahead and use that account. Sorry, get the private key for that account, and inside MetaMask, you can import that account using the private key. Yeah, so these are the accounts, and like we can also import the node address. The other one too. So this is how like we can create. Okay, so these are the pre-funded ones, and if you want to like send the Ether, you can just simply send it using these. So like after it is finished, we can like see the transaction, and in case, so let it finish. So, and in case if you want to deploy a smart contract or develop and deploy smart contract, you can like in a quick way, you can simply use the Remix ID. which is actually a developing IDE for both Solidity and Viper languages. So when we load, this will be the default. Yeah, so I think that transaction is confirmed. As you can see, we have sent some Ether to this particular account. And as you recall, we didn't add the first account or this account to be to have write permission to the network. So let's see if we send back some money, we'll be able to do that. So yeah, so I'll just send it back and let's say 1 Ether. Confirm. Yeah, so that transaction failed due to the fact that this account doesn't have permission to send any transaction to that transaction to the network. So yeah. Okay, so in case how we can deploy a smart contract. So I'll use the default smart contract provided by the Remix ID. This is a smart contract to store and retrieve some values, a numerical value. Now, how we can do is that we can connect to MetaMask using Remix ID. To do that, we can first we need to compile the smart contract. Then we can use the deploy and run transaction plugin to establish connection. So we'll be connected to the second account, the account which we have Ether. And everything is same as usual. We can deploy the smart contract, and we need to provide Ether for that. And yeah, the transaction is completed. We can store a value. Yeah, so it will take 15 seconds as you can. Yeah, so that's also confirmed. And if you retrieve, we can get that value. So it's as simple as it. Just the running is only the different things are the running of the node and the additional privacy and protection mechanism provided by the Besu in case we are running an actual, in a private network using Besu. So everything else is same as we operate within the Ethereum community also. They have provided us with a very great client that has a seamless connectivity with the other tools in the Ethereum network also. Now, yeah. So what's the timeline?
Ananthan, you can conclude. It's almost time.
Okay, so I'll just show you guys a quick overview of how we can run an actual, how it will look like when we are completely configured it for an enterprise solution, or we are running for an enterprise thing, and then we can end the session. So if you guys want to do that for yourself, you guys can go to this location and use that. So I think there was one in the chat. So if a few members in a group want to make a private ledger for them, whether they want to create another network, or is there any other options in Besu? So basically, every node in the network are in that same network, and these groups are what we call a private ledger. So the groups of themselves are private ledger, and you can if you want to form something else with anyone else. So something else, then we can do that also. Okay, then let's see how we can execute another one. So you guys have heard about Quorum. I mean, you guys might have heard about Quorum, which was a blockchain network for private cases. That was a fork from Ethereum, which was started by JP Morgan, and later on it was acquired by Consensus and Inc. And we can create a Quorum network using Besu in case that we will be running an Orion privacy transaction node also. But we don't really need to worry about those. If you want to really have a quick look at what the most cases we have, then we can like use this command and everything will be done for you. So basically you need to have Docker on your system installed. Node.js, you can use the latest version. There is no problem with that, like 12x or 14x, there's no problem with using that. And in case if you're running on Windows, you need to install Windows subsystem, Linux. I mean that basically that Linux environment provided by the Windows. Then you need to configure that into the Docker. And in case of Ubuntu or Mac, you need to install Docker on that. Okay, so I also, pulling these different containers inside Docker takes too much time. So I already have like running, how mine running. So to close a Besu node, you can simply go ahead and use the Control-C option. So very smooth. Okay, I think I have the main over here. Yeah, it seems they're already running. So these were the guys that didn't let me run on 8545. So yeah, so any other. Okay. Now the containers and everything we have actually seven nodes inside that, which we have like a validator node and the Orion nodes associated with that. We can use a command called, it's actually a script and a shell script inside that, and we can use the receive. I already started it. So first, when you guys first do this, you will be using the start.sh. So yeah, sorry, everything is running. So list.sh to see all the endpoints that are necessary for this running. So that will take some time to pop up. If you guys have any doubts, you guys can ask. Otherwise, I'll just give you the overview. Basically, what we are going to see is that we'll see the Grafana node monitoring software and a sample D app. I hope you guys have heard about the Pet Shop, which was which is a famous decentralized application by a demo decentralized application by Truffle, which is also the development tool framework provided by Consensus. We'll also see how we can run that or connect that. So this entire suite provided by the Besu community or developers, you can run everything and you can like have a glimpse of how we can operate with this node. So if you guys have any doubts, you can ask, because this will be taking some time, because it's actually querying up all the necessary things that we need to run this network.
Ananthan, there's a question.
Yeah. I saw it. Thank you, sir. So what application Besu is best suited? So like, I think, are you like sharing about the use case scenario or something like that? Oh, okay. So I mean, all like if you like if it is an enterprise, like if you want privacy and not all the participants on the network doesn't want to like see these kind of transactions, then we can connect. Sorry about that. If you want to have a privacy and all those things, like if you want to have groups within the network, like sub chains within the network, like where we can interact with each other, like that, those kind of scenarios can be used where you can use Besu. And now like Besu provides with the proof of click and a PBFT consensus algorithm. We can use them in a higher transaction rate also. So yeah, basically those kind of scenarios fits these, fits the use case of Besu correctly. Oh, okay. So just like the APIs, using those API endpoints, we can just explore them all over. Like all of the connections over here, you can like use the permission groups and all those using these connections. We can use them to provide the permissions and who can write and read into the network also. I don't know, looks like this is taking some time, and I'll just stop the existing containers and stuff. Okay, to start again, you can use the resume.sh. I just established connection to this current network. I think that is running on 8.45. Yeah, my computer is getting very slow. This might be already up, and this command might be able to fetch that. Let's see if it is up or not. And if, yeah. No, it hasn't been started yet. Yeah, so I think my computer is not able to take up the load of running all those nodes and all those containers together. So
That's all right, Ananthan. So
yeah.
I think we can wind up the session. It's already late. So so it was a wonderful session, Ananthan. So I think we can end it right now. So
Yeah.
I think you were trying to run the quorum node, and
Yeah.
it was.
I was trying to run a quorum example network, but that takes up too much memory and processing power. So that's why.
Okay, that's fine. So this was a wonderful session by Ananthan, and we had a introduction to Hyperledger and Besu by Mr. Julian Gordon, and I think we can conclude the session. Hi, Julian.
Hi, thank you. Great session. Thanks, Ananthan. That's wonderful.
Yeah. So thanks, Julian. Thanks, Ananthan. So now we will go ahead and take some questions if there are any. So to anyone, to Julian or Ananthan, if the participants have any questions, you can ask now.
I think it's been a long day.
Yeah, it's a wonderful session. Yeah. So I have one question for Julian. Like, how do you see Besu in the next couple of years in terms of the overall Hyperledger ecosystem? Like, how do you see the future of Besu?
Well, I think Ethereum and Besu is strong, right? So I see it growing and growing and growing. Of course, the question is how does that relate to Quorum? And that I think we're going to find out as well, right? Which is exciting, right? Those two are now under the same kind of consensus. So no, I see it growing. No, it's very exciting.
Okay, cool. So that's all for today's session. So it looks like we have covered everything. Thanks once again. Thanks for the wonderful session by Julian and Ananthan. It was a pleasure being with you all. We appreciate all the participants staying here for listening in, and we will see you at the next session.
All right. Thank you. Thank you, everybody.
Thank you, everyone.
Take care.
Bye.
So
Cheers.
those who want to go back to the Blockhash Live, the event link is there. So Julian, you are also free to join us there, and if you are time. So
We'll do. All right. Take
the
care.
participants can go back using the link. Bye, guys.